So another important reason why we can have high layer 2 retransmissions is low SNR. Okay, low SNR can actually trigger high L2 retries. It's a very important reason, and again a very commonly seen issue in the networks. Okay, so what is SNR? Let me just spend 2 minutes on explaining what SNR is. A lot of folks think it's signal to noise ratio. That's the full form of SNR, but it's not a ratio. Okay, so please keep this in mind. Signal to noise ratio, SNR, is not a ratio. Okay, it's the difference between signal and noise in decibels, as simple as that. So it's signal minus noise equal to SNR in dB. Okay, so for example, if I have a signal of minus let's say I have a signal of minus 70 dB, okay, and dBm, and I have a noise floor, ambient noise floor of, let's say, around minus 95 dBm, right? So in that scenario, the signal minus noise, that is the SNR of that client, will become how much? Signal is minus 70 minus 90, which is minus 70 plus 90 becomes 95. It's 95, right? Let me change that to 90, for example. Okay, let me change that to 90. Yeah, okay. So this becomes 20 dB. Now the SNR of 20 is what I get for this particular client. Okay, now an SNR of 25 and above is considered, as a standard practice, it is considered 25 and above is good. SNR which is below 18, or I would say in current scenarios, long back we used to have this discussion in the Wi-Fi forums that anything beyond 10 is bad. Okay, but I would say in current scenarios, I would say anything beyond less than 20 is bad. So you should try to target SNR anything in the range of 30 to 35, or 25 also should be fine, and that is good. But SNR less than 20 or 18 or 17 is something which should be worked on, right? So everything, and this is pretty much what's going to happen if the network is not designed properly. So what really does it do? So SNR less than 20 or less than 15, which is not acceptable in the network, is going to cause data corruption. Okay, because if the SNR is less, the receiver will not be able to hear the signal properly, will not be able to decode the signal properly, and hence we will see data corruption. And when data corruption happens, the destination does not send an ACK because it cannot decode. If it cannot send an ACK, it will result in high layer 2 retries, right? This is what we were looking to do at the beginning of the video. So we wanted to see how low SNR can cause this to happen. Now there are some things that you should know. For a data network where mostly people use data, when you design a network, these are some design considerations. Okay, yeah. So when you design a network for data network, try to have the when you do a predictive analysis or a predictive survey using Ekahau or any other tool, try to have the primary RSSI value set as minus 67 dBm, which means at each place in the network on the ground, the client should be able to receive at least this much RSSI value. Okay, this is the primary RSSI value. Okay, now when it comes to voice networks, what I do is the primary RSSI value, I move it to minus 65 dBm. See, I'll tell you why. This value a few years back was minus 70 dBm. They used to say, yeah, minus 70 should be okay. And for voice network, this was supposed to be minus 67 dBm. Okay, these values were considered good, but this was many years back. Nowadays, when we design networks, what I personally do is I make sure that I have some buffer and I keep these values as my primary RSSI value when I design networks for voice and data, just to make sure I have enough margin of error and the clients on the ground do not have any problems when they when they interact with an access point, right? So let's take an example of this. Now what I'm trying to say is, let's say there's an access point here, okay, and this is an ambient noise floor. I'm just going to draw this like this so that you get an idea of what I'm doing. This is an ambient noise floor of, let's say, minus 95 dBm. This is my noise, okay. Now there's one client which is close to the access point. Anyway, the signals are going like this, okay. Now there's one client right here, one laptop that is connected at a signal of minus 70 dBm. So the RSSI, that is received signal strength indicator, is minus 70 dBm, and thus it is at an SNR of how much? 25, right? Similarly, I have another client right at the corner of this room which is getting a signal of RSSI value of minus 85 dBm, for example, and thus it is connected at an SNR of how much? 10 dBm, right? So that's how, clients nearer to the access points usually don't have low SNR unless there's some other issue going on, which we will discuss. I mean, there are other things also that we need to keep in mind, but usually clients away from the AP will experience low signal strength coming from the AP, and hence you will have lower SNR. So when you design a network, when you do a design initially of the network, before the network is deployed, make sure you do a site survey, pre-deployment site survey properly. Make sure you have enough margin of error, something called fade margin, that you need to take into consideration. Again, these topics are discussed in the fundamentals course, so yeah, if you get a chance, go through that as well. Fade margin, you need to make sure you have the right RSSI value set for the primary coverage and the secondary coverage, okay. You need to make sure you check with the clients what kind of apps they are going to use, what kind of clients they're going to use, what kind of bandwidth do they want from the users to use, so that you take into consideration all these things before you design the network. And once these things are done right, there'll still be hiccups, but at least you'll be in a better position to know that what's really going on. So design the network well, and more often than not, you're not going to run into this low SNR problem, right? Have enough APs. Do not design for coverage. That's another point. Do not design the network for coverage. Always design the network for capacity. The network for coverage used to be designed many years back when the APs were expensive. The Wi-Fi clients were not that much. So the focus of the organization was to just provide coverage to each corner of the access of the building. They'll just put one AP on the floor and just let it cover the entire office space, and then just give the clients coverage. Nowadays things have changed. Each user carries two devices, the laptops, the smartphones, the tablets. All those people are carrying a lot of devices, and now the performance is more of a concern because every device is on Wi-Fi. We want to make sure we have enough capacity on the network so that each client can be serviced well, right? So design for capacity, not for coverage. If possible, design for 5 gigahertz. Anyway, these are all design considerations covered very well in the site survey fundamentals course, something which you might want to look at. Okay, cool. So in the next video we'll talk about what mismatched power settings is, and then I think that's also another cause of high layer to read transmission. So yeah, see you in that video. Thank you.